Hello and Assalamu alaikum. Today we will be doing Cambridge IGCSE Chemistry, February March 2021, paper 4-2, total time for which is 1 hour 15 minutes. So the total marks are 80. Question 1, you're given a list of particles with the number of protons, neutrons, and electrons, and there are questions related to it. Each letter may be used once, more than once, or not at all. So state which of the particles A to I is an anion. Ions are charged particles, and anions are negatively charged particles, and cations are positively charged. So the element or the particle which will be having more protons, more electrons, or the number of electrons is greater than number of protons, this means that it is an anion, because it will be having more electrons, which means that it has gained an electron. And anions, what do? They gain electrons. As for cations, they have fewer electrons than protons because they lose their electrons, so the charges don't cancel. The number of electrons is greater than the number of protons, which is why they don't cancel out, and there's a net negative charge on the particle. So we just have to check which particle has more electrons than protons, and over here it has one more proton than electron, equal over here to over here, two more electrons than protons. So yeah, this is an ion with a 2 minus charge, because it originally had 16 electrons, because in an atom we know that the number of protons and electrons are equal, but here they have written it has 18 electrons. This means that it has gained 2 electrons, so it should have a net charge of 2 minus, and it is an anion, which is E. Next are cations. So cations should have more protons than electrons. So A should be there, because A has one more proton than electron. So A should be there. A, and if all these have, after A, all these have same protons and electrons. F has equal, G equal, and here again we have more protons than electrons. So I are noble gas atoms. So noble gas atoms should have a configuration in which the outer shell is full. Outer shell has the atom has 8 outer shell electrons. 8 outer shell electrons. So if you look at the electronic configuration of this D, 2 8, because total should be 10, so 2 plus 8 10. So this is the electronic configuration of D, so D is the answer. Next, if we look at E, E also has 18 electrons, and it has an electronic configuration of 288, but the problem is that it is an anion. We have already decided in part 1. So it is not a noble gas atom, it is an anion, because noble gases don't gain or lose electrons like this. As for this is also 2 8 and 7, so it should be in group 7. This is 2 8 8, yes, so this is now again a noble gas atom. G, D and G. I is not possible again, because it is an ion. So I again is a cation, so not a noble gas atom. Next is a halogen atom. We already decided halogens are atoms from group 7, elements from group 7. We call them halogens. So this is a halogen, which is F. Is a group 1 atom. Group 1 atom means the number of outer shell electrons should be 1, because the group number is the same as the number of outer shell electrons. So the configuration of 1, electronic configuration in which the outer shell has 1 electron. So if we look at the atoms over here, we have already looked at these. This should be 2 4, so it is in group 4 only. All this we have looked at. If you look at H, it is 2 8 and 8 again and 1, so it has one outer shell electron, which means it is in group 1. So H is the correct answer. Have the same nucleon number. So the nucleon number is the sum of protons plus neutrons, sum of protons and neutrons. So that should be equal for these two atoms which they're talking about. So the nucleon number of A is 1, 12, 14, 20. We're just adding the protons and neutrons. 32. As for this, 17 plus 18, 35. Again 40, 39, 40. So G and I both have 40. So G and I is the correct answer. Causes acidity in aqueous solution. So the element responsible, or the particles responsible for acidity in aqueous solution, is hydrogen ions. So hydrogen, if you look at the periodic table, what is hydrogen like? Hydrogen has only one proton and one electron. It does not have a neutron. So the neutron being 0, this can only be hydrogen. Now why does it have electrons? Because it is H plus ion, so it has lost electrons. So A is the correct answer. Is used to define the relative atomic mass of elements. So the relative atomic mass is the mass compared to the 1/12 of the mass of a carbon 12 atom, which means that it should be a carbon 12 atom in which the nucleon number should be 12, as in the periodic table. If you look at the periodic table, carbon has nucleon number of 12, and the number of protons 6. So nucleon number 12 is only B, and the protons is 6 over here. The problem with C was that we did not have the neutrons as 6, and we did not have the mass number as 12. So the correct answer is B. Explain why B and C are isotopes of the same element. So isotopes are atoms. They are atoms. They are atoms having same proton number and different neutron number or nucleon number. In other words, they have the same number of protons but different number of neutrons. Next, the elements shown are gases at room temperature and pressure. State which one of these gases is green. So this is pure. Recall chlorine is a pale yellow green, yellow green yellow gas. Pale yellow is fluorine. The gases shown exist as diatomic molecules. State the name of another element which has diatomic molecules and is a gas at room temperature and pressure. So diatomic molecules, this means it should not be a noble gas because they are monatomic. It is a gas at room temperature and pressure. If you look at group 7, we have fluorine from the top of the group as a gas. All other gases are already mentioned in the question. So fluorine is the correct answer. When separate samples of each of these gases are placed in a container, they will diffuse. Describe why these gases diffuse. So gases diffuse because of the random motion of the particles, which is called Brownian motion. Due to the random motion of particles. State which of these four gases has the highest rate of diffusion. So the rate of diffusion depends on the MR. The higher the MR, the lesser the rate of diffusion. The lower the MR, the higher the rate of diffusion. Inverse relationship. So the gas having the lowest MR should be obviously hydrogen. So hydrogen, because it has a mass of 1 only. So the gas is hydrogen, and the explanation is that it has the lowest molecular mass. Nitrogen, oxygen, and other substances are found in clean dry air. State the percentage of nitrogen in clean dry air. This is pure recall again, 78%. Other than nitrogen and oxygen, identify another element found in clean dry air. So you can't write CO2 over here. We know that noble gases are present, and from noble gases we have to write an element which is present in air. So argon is mostly found from amongst the noble gases in air. Identify a compound found in clean dry air. So this is a compound, carbon dioxide. Nitrogen and oxygen can be separated from liquid air. State the name of this process. So separating different liquids is called fractional distillation, in which they are separated according to their boiling points. So air is first converted into liquid, and then the individual liquids, liquid nitrogen, liquid oxygen, is separated by referring to the boiling point. This question is about ammonia. Nitrogen reacts with hydrogen to form ammonia in an industrial process. Name this industrial process. This is, as we know, Haber's process. And the manufacture of sulfuric acid is contact process. State the meaning of the symbol. This symbol indicates that the reaction is reversible. State the conditions used in this industrial process include units. So the temperature is 450 degrees Celsius, both in Haber's and contact process, and the pressure is over here 200 atm or 20,000 kPa or 200,000 kPa. So whereas in sulfuric acid it is just 2 atm. Name the catalyst used in this industrial process. We know this is iron, and in sulfuric acid vanadium 5 oxide is used. If the pressure is increased, the yield of ammonia increases. Explain why in terms of equilibrium. So when the pressure is increased, the reaction side having the fewer moles of gas is favored. So the moles of gas over this side is 2 and on this side is 4. So when the pressure is increased, the side with fewer moles will be favored, so the reaction will move in this direction, because the equilibrium shifts towards the right due to fewer moles of gas on the right side. If the temperature is increased, the rate of reaction increases. Explain why in terms of particles. So when the temperature is increased, the kinetic energy of the particles increases. There are more collisions between particles, or the frequency of collisions increases, and more particles have energy equal to or above the activation energy, because as you know there is a threshold point at which the particles energy needs to rise so that they can react. So until and unless the energy of the particles is above or equal to that point, they cannot react. So to provide the particles with this energy, temperature is increased. So explain why when temperature is increased, the kinetic energy of the particles increases and they move faster, and more collision occur, or better to write more frequent collisions with respect to time, because frequent means per unit time. More frequent collisions between particles occur, and more particles have energy equal to or above the activation energy. ammonia reacts with sulfuric acid to make a compound which is used as a fertilizer. Write the chemical equation between ammonia and sulfuric acid. So ammonia is NH3 plus sulfuric acid. Now the ion present in ammonia is actually the ion which forms is NH4 plus, the positive cation. So this positive will react with the negative sulfuric sulfate ion, which will give us NH4SO4. But the difference is that SO4 has a charge of 2 minus. So this will go over here and cross multiply, you will have a bracket, and hydrogen will be formed. Or no hydrogen, because this is formed in which an extra hydrogen is already present. So no need for the hydrogen, and we were given the hint that it is used as a fertilizer. So this ammonium sulfate is a fertilizer substance in which nitrogen is obtained from. So the equation is balanced except for this. There should be a 2 over here because there are two nitrogens on the right side, so there should be two nitrogens on the left. Now we have six hydrogens and two, so eight hydrogens on the left side and eight hydrogens on the right. 4 twos are 8. A student wanted to make some zinc chloride crystals. The student followed the procedure shown. Add excess zinc powder to dilute HCl to form aqueous zinc chloride. Remove unreacted zinc powder from the aqueous zinc chloride. Heat the solution until it is saturated. Allow the saturated solution to cool and remove the catalyst crystals that form. So you should be remembering these steps because you can get these in to state as well. You can get how to make produce a salt, what reactions you need to make to produce the salt. Write the equation for the reaction in step 1. So what was happening in step 1? Zinc reacted with dilute hydrochloric acid to form zinc chloride. So zinc is a solid metal plus HCl is aqueous, acids are aqueous, to form zinc chloride. The zinc has 2 plus charge, chlorine has minus 1, so zinc chloride is like this. This should be aqueous, they have told us. Plus hydrogen gas should also be formed because we know the reaction of metals with acids always gives us a salt, which is zinc chloride, and hydrogen gas. So you just need to add 2 over here to balance this. Explain why excess zinc powder is added. Because we need the complete acid to react. If the zinc powder was not in excess, if it was a limited amount, then maybe the entire acid does not react, so it will interfere in the reactions. We need the complete acid, we need all of the acid to dissolve, yeah, to react. If this was not excess, but it is possible that zinc powder finishes before the acid. So the answer will be so that all the acid has reacted. Next, suggest how unreacted zinc powder is removed in step 2. So it's zinc powder which is insoluble in water. So insoluble substances are separated by filtration. A saturated solution is formed in step 3. Suggest what is meant by the term saturated solution. So a solution in which no more solute can dissolve is a saturated solution. A solution in which no more solute can dissolve means it has been saturated. It cannot further dissolve more solute. More solute dissolves at a given temperature because temperature affects the solubility. If we increase or decrease the temperature, it might affect the amount of solute dissolving. So that's why a given temperature, a fixed temperature is needed. Explain why crystals form as the solution cools in step 4. So as the solution cools, the same thing which I was talking about, temperature affects solubility. So as the solution cools, its temperature decreases, The solubility of the zinc chloride solid decreases. Solubility decreases. So as temperature decreases, solubility means the ability to dissolve of zinc chloride decreases. Name two zinc compounds which react with dilute HCl to form zinc chloride. Okay, so zinc compounds. We need zinc compounds. So zinc oxide, which is a basic oxide, so it should react with an acid. It will react with an acid to produce zinc chloride plus H2O plus H2O. No need for the equation. They're just asking about the compounds. So zinc oxide and zinc carbonate. Zinc carbonate. Next, if excess calcium metal is used instead of excess zinc powder. In step 1, pure calcium chloride crystals do not form. Explain why. Okay, so first zinc was being used and the solution was aqueous HCl in which water was also present. So zinc powder does not react with water, it only reacts with acid. Whereas for calcium, the calcium also reacts with the water. So this is why pure calcium chloride is not formed. Let's look at the stem of the question again. A student wanted to make some zinc chloride crystals. The student followed the procedure. Add excess zinc powder to dilute HCl to form aqueous zinc chloride. Okay, so dilute HCl means water has been added. So zinc reacts with, yes, zinc reacts with acid to form the zinc chloride. As for calcium, if calcium is reacted, it also reacts with the HCl and the water. So when it reacts with water, what is formed? Calcium oxide. So this is why it's not correct. Calcium hydroxide or oxide. So the reason is that calcium can react or will react, in fact, will react with water. Okay, so a titration question. Some salts can be made by titration. In a titration experiment, 20 cm cube of aqueous sodium hydroxide reacts exactly with 25 cm cube of 0.1 moles per dm cube dilute sulfuric acid to make sodium sulfate. The equation is given. Circle the name of the type of the reaction that takes place. Of course, an acid and a base are reacting, so neutralization. Calculate the concentration of the aqueous sodium hydroxide in grams per dm cube using the following steps. So a series of steps are given. First, calculate the number of moles of dilute sulfuric acid used. So we have the concentration of sulfuric acid and the volume. And the formula we can use moles equals to CV, concentration times volume. Concentration is 0.1 and volume should be converted into moles. So this will be 0.1 times 0.025, which is 0.0025. Next, determine the number of moles of sodium hydroxide which react with the dilute sulfuric acid. So according to the balanced equation, the mole ratio is 1 is to 2 acid and NaOH. So the moles of NaOH should be double the moles of the acid. So multiplying this by 2 will give the moles of NaOH, which will be 0.005. Calculate the concentration of the aqueous sodium hydroxide in moles per dm cube. We are given the moles and the volume also 20 cm cube. So N equals to CV again, and for the concentration N over V. Moles are 0.005. Volume is 0.020. 20 cm cube was there, yes. So in dm cube 0.020. The answer to which will be 0.005 over 0.02. 0.25, yes. Now calculate the concentration of the aqueous sodium hydroxide in grams per dm cube. So this is moles per dm cube, and this is we have to go into grams per dm cube. Dm cube is the same, we only have to convert the moles into grams. So the moles, to convert the moles into grams, so to go from to for going from moles to gram, we need what? The mr, and when we go into gram, the mr is multiplied by the number of moles. So the mr will be, these are the number of moles. Multiply this by the mr of sodium hydroxide will be 40. So the answer will be 10. 10 is the answer. Next question. Organic chemistry. The table shows the names or structures of organic compounds P to U. Okay, give the letters of the organic compounds P to U that are unsaturated hydrocarbons. So unsaturated means containing a double carbon double bond, and hydrocarbon means only carbon and hydrogen. So there is no double bond over here. Propanoic acid has a functional group of COOH. So not, or let's just draw the structure. So it's not a hydrocarbon. But1-ene is an alkene, which is a hydrocarbon containing a double bond. So R, again, an alcohol. Just to be very fair, very frank, unsaturated hydrocarbons means alkenes in simple terms. So this is an ester. Esters are not unsaturated hydrocarbons. U is again an alkene containing a carbon-carbon double bond. So R and U. Describe the test for an unsaturated hydrocarbon. Test is the aqueous bromine, and it will decolorize. It decolorizes in the presence of, yes. But1-ene is an unbranched molecule. Name the unbranched isomer of but1-ene. So this was but1-ene. I'm not drawing the H. This was the but1-ene. Now we have to have another isomer, which means the same number of carbon atoms and hydrogen atoms, but a different name, a different structural formula. And we do not want a branch. So this double bond, if we shift it to the second carbon, and so this will be but2-ene. But2-ene. Draw the structure of a branched isomer of but1-ene. Show all of the atoms and all of the bonds. So if this is but1-ene, we just have to get a branch. So, and a branch over here, CH3. And they want all of the bonds, okay? So we have to draw all of the bonds. So this is now methyl propene, 2-methyl prop1-ene. How did we get 2-methyl? Because the carbon naming of the chain should start from where the double bond is. So 1, 2, 3. This is the highest number of carbons we can get in a straight chain. So this is the main parent chain, and this is a methyl group on the second carbon. Okay, so dodecane is an alkane with 12 carbon atoms. Dodecane can be cracked, okay, and it is containing 12 carbon atoms. It is an alkane. Alkane general formula is CnH2n plus 2. So we can apply the formula for on the dodecane. Okay, so C12H2n will be 24 and plus 2 will be 26. So C12H26. Give the letters of all the organic compounds that can be formed when dodecane is cracked. Okay, so when a large chain is long chain molecule is cracked, smaller chain molecules form, and they are all hydrocarbons. Only hydrocarbons should be present. So P, R, and U, all of them can be formed because they all contain 3, 4, or 3 carbon atoms. So they can be formed from 12 carbon atom chain. So P, R, U. Name the reagent and suggest the conditions needed to convert organic compound U into organic compound S. So what's U and what's S? From U to S. So U is an alkene and S is an alcohol. So we have studied this reaction, alkene to alcohol. What do we need? We need the reagent. We need the reagent steam, and we need a catalyst, phosphoric acid, H3PO4, and the conditions should be a high temperature, 300 Celsius, and a high pressure, 60 atm. So these are the conditions: steam plus phosphoric acid. Conditions are 300 degrees Celsius. Organic compound S can be converted to organic compound Q by reaction with an acidified agent. Reagent, name the type of chemical change that happens to organic compound S. So S and Q, S to Q. S is an alcohol, Q is an acid. So alcohol to acid. And with an acidified reagent, so this should ring a bell, acidified potassium magnate we have studied. And the type of chemical changes, oxidation, and oxygen atom has been added and hydrogen removed. So name the acidified reagent, potassium magnate, KMnO4, or potassium magnate. You can write in words also. Organic compound T is made by reacting two compounds together. Name the homologous series that organic compound T belongs to. So this is T. This is an ester. We already did it. Ester. Name the two compounds which react together to make organic compound T. And we have to draw the structures as well. So that is methyl butanoate. Methyl butanoate. Methyl butanoate. So as we know, this part of the name is from the alcohol. An ester is formed when an alcohol and an acid react in a condensation reaction, and this is from the acid. So but means four carbon acid, and methyl means one carbon acid alcohol. So this will be methanol, and this will be butanol. Okay, so butanoic acid, butanoic acid. So we have to draw these two structures, and name we have already done. This is the two compounds are methanol and butanoic acid. Methanol is just one carbon and an OH should be present, or we have to show all of the atoms and all of the bonds, so OH. And for this, we have butanoic acid formula: one, two, three, four carbons, and then a functional group. All the hydrogens done.
Deduce the molecular formula of organic compound T. So the molecular formula of compound T, if we just draw the structure of molecule compound T, methyl butanoate. So this will remain the same, the acid part. What will happen is this OH will go, or maybe just let me bring this down. This OH will go, and in the alcohol, this H will go. So this O will then directly bond to this carbon. If I draw the alcohol also over here, C C O H H H H. This H and this OH will be gone, and water will be formed, and the remaining molecule is our molecular will give us the molecular formula. So how many carbons? One, two, three, four, five carbons. C5. How many hydrogens? One, two, three, four, five, six, seven, eight, nine, 10. H10. And how many O's? One and two. C5H10O2. Yes. Polymers are large molecules built up from small molecules. State the name given to the small molecules from which polymers are made. Of course, monomers. The formula of a polymer is shown, and we have to draw the structure of the monomer. Okay, so this is the chain from which the polymer is being formed, and there was a double bond originally over here, and we did not have this bond. What happened was this double bond broke, and the chain continued. So and this is a molecule containing four carbon atoms. So it is butene, and the double bond is present on the second carbon. If we name it, this will be the naming one, two, three, four. So the double bond is on the second carbon, butene. So we just have to draw butene, C H3, C double bond, and another carbon. So let's complete the structure. What happened was this went down, this also went down, this double bond broke, and this continued on forever. Okay, state the type of polymerization used to make this polymer. This is addition polymerization in which a double bond is broken and no additional product is formed. Addition. Three amino acids are shown. They combine to form part of a natural polymer. Name the type of natural polymer formed when amino acids combine. We know this is protein. Amino acids are monomers of protein. Complete the diagram to show part of the structure of the natural polymer that forms when these three amino acids combine. Show all of the bonds. Okay, so in this what will happen is this is basically NH2, right? So in this H and this OH again, they escape and water is formed, and this C is directly this CO is then directly bonded to the N, and this H remains with the N, and this continues on in every monomer. So this is NH, and this will be shown for the continuation. Over here again C O, and over here we had N H. So this is joined from here. Now again we have a COOH over here. So CO, the same will be repeated then. Exactly the same. Then again CO and continuation. So this is basically the amine group. Why is this called amino acid? Because this is the amino group and this is the acid group. So amino acid. Name the type of chemical reaction that takes place when this natural polymer is converted back to amino acid. So this was condensation when it was polymerized, and now when we break the polymer, we need to add the water back. If we react this by acid or water, then it will be converted back to the monomer. So this is reaction with water, which is hydrolysis, in which water is being used to lysis means destroying or breaking the bond. Okay, so I think we've completed. Yes, thank you so much. Jazakallah khair.